Hello. In this example, we want to give the domain and range of each relation. We want to use the vertical line test to determine whether each relation graphed is a function. I want to determine if each one is a function first here. We want to look at the vertical line test. The vertical line test is effectively a way of looking at a graph and determining if what you see is a function or not. A is simply a set of coordinates graphed on the coordinate grid. What this means is that you can actually really just look at this and determine if this is a function or not. However, I'm going to use the vertical line test. A vertical line test basically says that for every vertical line that you can graph, all the vertical lines have exactly one point through that vertical line, or at least at most 1 point. You can have 0 points. In other words, if I graphed a vertical line over here, there's not a point there. Therefore, it still passes the vertical line test as long as there's not 2 points on top of each other, or 3 or more. So notice if I included this point right here as part of the relation, then this would go from a function to not a function. Okay, so this A, yes, it is a function. Let's look at B. B is clearly not a function because I can draw this vertical line here, and I have a point here and here that is in this relation and going through this single vertical line. So because of this, B is not a function. C is just a straight line, and if you look at it, think of having a vertical line start here and just slowly go across here. So because of that, this vertical line and this vertical line and this vertical line and this vertical line, all these vertical lines cross at only one place on this straight line. Therefore, C is a function. Now let's look at D. Some people get to the point where they're trying to overthink this. These are telling us that this graph is continuing up this way, and this graph is continuing up this way as well. And they start thinking that, well, it may start having more than one on a vertical line. Don't overthink these. This is a function. Just think of it as having a vertical line here, 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 basically a whole bunch of them, and it only crosses at one place on all of those vertical lines. Therefore, D is a function. Now, I want to go back to A, and I want to talk about the domain and range. The domain, again, is simply all of the x values. So if I go over here, I have -1, 0, 1, and 4 for my x values. So just put those in set notation. -1, 0, 1, and 4. Let's look at B. I'll come back to the range on A. For B, B, C, and D are actually a lot different than A, because all of these values, not just this point or this point, must be included. In other words, there's a point here, 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 a point here. Excuse me, 1 second. Okay, I'm back. All of these points must be accounted for. So, I can't simply write down exactly what the domain is, at least in this form. This is set notation. What I need is interval notation, because everything, including this -4 to this +4, must be included in the domain. Therefore, to do that, you write down the domain starts at -4 and it continues until +4, using these square brackets to show that it is inclusive of those endpoints. The same thing on C. If we look at this, notice that this arrow and this arrow show that this graph keeps going this way and this graph keeps going this way. But if we're looking at x values, that means that it keeps going that direction and it keeps going that direction. Remember, that's negative infinity and that's positive infinity. And everything in between must be included as well. Therefore, the domain here will be negative infinity to positive infinity. And make sure to use parentheses with infinity signs because infinity is not a real number. So if we look at D, D is much like C in the sense that it keeps going up like this. However, it's not just going up, it's going towards the left over here, so it's going to keep going towards the left, and it keeps going towards the right over here. So again, your domain here will be negative infinity to infinity. Now let's look at the ranges. The ranges are pretty much the same idea, except we start from the bottom to the top. So over here with just coordinates, it's -3, -1, 1, 2. So your range here is going to be -3, -1, 1, and 2. Look at B. The same thing is going to happen, just this time it's on the entire range here, not just -6 or 6. It's at everything including -6 and 6. So your range here is going to be -6 to 6. And notice I'm using interval notation now, which means I'm including -6 and including -6, and I'm showing that it's everything in between those two values, because there is an infinite number of points here between those 2 points. Look at C. Again, it's going up this direction and down this direction. Therefore, you start at this negative infinity, and you continue all the way up until you're at positive infinity. So your range here will be negative infinity to infinity. And if you look at D, D is a little bit different because at this point here, it's not saying you keep going down, it's actually going back up that way and back up that way. Therefore, this -3 is that lowest value. So your range actually starts at -3. I don't know what that's doing, but it starts at -3 and continues, excuse me, so it starts at -3 and continues all the way up to infinity because it keeps going up that way. Therefore, you end your range at infinity.